Hey guys, what's happening? So today we're going to talk about general angles and a little bit more about radians. Uh, not not much more. Just basically how to convert different degree measures into radian measures. Okay. Um, and let's just go ahead and get started. First thing we're going to talk about are angles and standard position. Okay. So go ahead and copy this and we'll get started. All right, so if you notice here, we have the initial side right here, okay? This is where your angle starts, and then it opens in this direction, and then it finishes here on this terminal side. So again, it's kind of like this. I think I've shown you my little angle demonstration here. So here we have a closed angle. So the measure of this angle, it's closed, is 0 degrees, okay? But then as I open it, look at this, I'm opening it. There's maybe about 30 degrees right about there, 45 degrees, 60 degrees, and then here's 90 degrees, right? Okay. And so again, this is my initial side and this is my terminal side, okay? And then I could keep opening it. So there's about 135 degrees, and then I open it all the way to a straight line and there's 180 degrees, okay? Still I have my initial side and my terminal side, okay? All right, so that's basically how angles are in standard position. And just really quickly, let's just kind of get warmed up with something like this. Let's find an angle that measures 240 degrees, okay? And then if you finish this one quickly, how about one that measures 500 degrees? And then if you can think about it, let's try to do one that measures negative 50 degrees. What do you think that angle would look like? Okay. All right, so let me go ahead and just draw some axes here, X and Y axes. Doesn't have to be perfect, okay? Again, this is the center of my axes, the origin, whatever, that's also going to be where the vertex of your angles are going to be, okay? Again, we start off with 0 degrees, 90 degrees, 180 degrees, 270 degrees, all the way back to 360 degrees. And guess what? You can keep on going around the circle, okay? So I'll show you that in a sec. So right now, 240 degrees, that's our first one we want to get warmed up on. Well, take a look. We start off with 0, open it up to 90, to 180, to 270. We've gone too far. How far back do I need to go? I need to go back 30 degrees, okay? So right about here is, if I start here, okay, I'm not going to draw this. See if you can just follow. I start here at the initial side and I open it up all the way around to here, okay? All the way around to here. So this angle right here, this very obtuse angle, okay? That's really obtuse, I guess. I don't know, does obtuse go bigger than 180? I can't remember. Anyway, but this big old angle right here is 240 degrees, and I'm just going to mark it right here. 240 degrees is going to be right there, okay? But I'm talking about this all the way around to here, okay? Okay, cool. So that's 240. Now let's talk about 500 degrees. I don't see 500 written anywhere. That's right. You have to go all the way around. If you've gone all the way around an entire circle, you've gone 360 degrees. Well, how many more degrees do I need to go to get to 500? Okay, I need to go 140, right? Okay, so let's go another 140 degrees. Okay, so I'm going to go all the way to about here, okay? There's about 140 degrees right there, okay? So I'm just going to go boom. All right, so this is 500 degrees, okay? And I'm going to talk about coterminal angles in a second, okay? But do you remember how many degrees it was? All the way around was 360, but then how many more degrees? Okay, well, it was also 140 more degrees. So we'll talk about this in a second, but 500 and 140 have the same terminal side. They're called coterminal angles, okay? So anyway, that's coming up. And then finally, 50 degrees, but it's negative 50 degrees, okay? Any guesses? That's right, we're going to start here on the initial side and we're going to go backwards 50 degrees, okay? Which is right about here, okay? Negative 50 degrees is just about here, okay? So negative 50 degrees going this way, okay? That's negative 50 degrees, okay? Just curious, can you think of what angle would match up with that terminal side if I opened it up this way? Okay, well 360 take away 50, what is that? 310, right? So if I open it up all the way around this way, wouldn't that also be 310 degrees? Notice how they're all kind of the same, okay? Same terminal side, just different numbers depending on which way you go. If you go clockwise, you're going to get negative values. If you go counterclockwise, you get the positive values, okay? And then if I wanted to, I could go around all the way again, right? I'd have to go 360 degrees. What else could this angle be right there? Okay, well, 310 plus 360 more is 670, okay, if I did my math right. Okay, so what I'm talking about are coterminal angles. So I'm going to talk about those right now. Okay, so here we go. Let's talk about part B. All right, coterminal angles. All right, and I'm going to say, let's example, find positive and negative numbers or angles that are coterminal with, okay, and let's do two examples. Negative 45 degrees, okay, there's our first example. All right, so here I'll just sketch really quick, and you don't even have to do this. It's actually much easier. You don't have to do all this work. But if I have negative 45 degrees, remember this is 0, right? This is 90, 180, 270, 360, okay? But if I want negative 45, that means I have to go back 45 degrees, right? Okay, so that's going to be right here. That's negative 45 degrees, right? I could put negative 45 for this angle, right? But I usually put it here on the edge, negative 45 degrees, okay? So now what I want to do is find a coterminal angle. Remember, this is my initial side, and this is my terminal side. So what I want to do is find another angle measure that shares that exact same terminal side. That's coterminal, okay? So all I have to do really, okay, watch. If I go around from this angle right here, and if I go around 360 degrees, won't I land back on that angle? Okay, so what's a good way to do it? That's right, you can go negative 45 plus 360, and what does that equal? I think that equals 315 degrees, doesn't it? We'll try it. Go 315 degrees. Yep. So right here, there's 270, right? And 270 plus 45 more, that gives you 315. Okay, so there's one coterminal angle, 315. We also need a negative one, right? It says find a positive and negative. Okay, so if we start with negative 45, what do you think I have to do to get a negative coterminal angle? That's right, keep going in the negative direction another 365 degrees. So I'm going to subtract off another, so minus 360 degrees. Okay, and that gives you what, negative 405 degrees, I think? All right, okay, negative 405 degrees. So there's a positive coterminal and a negative coterminal with negative 45 degrees, okay? So the gist of it is just add or subtract 360 degrees. Okay, that's the main idea for finding coterminal angles. Okay, that's all you have to do, really. Okay, I'm not going to overcomplicate it. Okay, I don't even think I'll give you another example. All right, so let's do one last thing. We talked about general angles. Now we're going to talk about radians. Now, a lot of you guys already know about radians. Here, let me get my unit circle. All right. Let's see, where's one that's already partially filled out? There we go. Okay, there's my unit circle here. All right, so I know you guys already have the 30 degrees, and that's the same as pi over 6 radians, okay? Did you get 45 degrees? Well, remember, 180 degrees is the same thing as pi, so how does 45 compare to 180? Well, that's a fourth of it, right? So what do I do here to get radians? Well, it's going to be a fourth of pi, so it's going to be pi over 4, okay? Pi over 4 radians, okay? What about 60 degrees? Well, how does 60 compare to 180? Well, 60 is a third of 180, so wouldn't the radians be a third of pi? So it's pi over 3, okay? And so watch this. If I count by pi's over 6, I have 1 pi over 6. Here's 2 pi over 6. Wait, I thought you said it was pi over 3. Well, doesn't 2 pi over 6 reduce to pi over 3? It sure does, okay? So you can count by pi over 6's, okay? Or you can count by pi over 3's. Here you can count by pi over 4's. Watch this, 1 pi over 4, 2 pi over 4, which reduces to pi over 2, right? 3 pi over 4 right here. So this is 3 pi over 4, okay? Here's 4 pi over 4, but doesn't 4 pi over 4 cancel to just pi? Okay, here's 5 pi over 4, so 5 pi over 4. So that's, if you haven't already figured that out, that's how you could go around the unit circle in radians. But here's the thing. These are for very specific angles. 30, 45, 60, 90, okay? 0, okay? Right? 0 degrees is 0 radians, okay? So anyway, how do you do it for the angles, the degrees that aren't on this? So that's what I'll show you right now, okay? So, converting degrees into radians. So what am I on? Part C. Part C. Convert degrees to radians, or vice versa, okay? And so let's just say I have, just remember, what you need to do is remember this, right? Remember, this is the main thing, that 180 is equal to pi, right? 180 is equal to pi. So let me ask you something. What does 180 divided by pi equal? What does it equal? Well, if they equal each other, 180 divided by pi, that's the same thing as 180 divided by 180, which is just 1, right? So that equals 1. So watch this. If I have an angle measure of 125 degrees, and I wanted to convert it from degrees to radians, I'm going to multiply it by 1. Okay? Watch. I'm going to multiply this by 1, but I'm going to multiply it by pi over 180. Okay? Isn't this 1? So 125 degrees times 1 is still 125 degrees. I have not changed the value of it, right? But watch what happens now. I can reduce these guys, okay? And 125 and 180, I see that 5 goes into both of these, okay? So I know then that 5 goes into 125, let's see, 25 times, okay? So I still have times pi, okay? 5 goes into 180, let's see, what is that, 36 times? So 125 equals 25 pi over 36 radians. Really, that's all you got to do. Here, let's try another one. How about 50? How about 50 degrees? Okay, well again, multiply it by pi over 180, which is just multiplying by 1. Okay, again, I see 10 goes into both of these, so this is going to be 5 pi over 18. That's how you write 50 in radians, 50 degrees to radians. Let's go the other way around, okay? Let's do something that you guys already know. Let's do 5 pi over 4, okay? What if I wanted to convert 5 pi over 4 radians, okay, into degrees, okay? Let's try it. 5 pi over 4, okay, that's radians. So if I wanted to convert that into degrees, instead of multiplying by pi over 180, I'm going to multiply by 180 over pi. I'm still multiplying by 1, but watch what happens now. The pi's cancel, right? Okay. And 180 divided by 4, let's see, what is that? 45. So this turns into 45, okay? And 45 times 5, can I do that? Let's see, 90, 180, 135. Did I do that wrong? No, 235? 235. There we go. Shoot, I'm sorry. I don't want to mess this up. I'm just looking at the clock and I'm running out of time. Hang on. Let's just do this. 5 times 45, 225. Okay. Whew, man, 225. So guess what? That's this guy right here, 225. So just do the opposite. Okay? All right, guys. Hope that was helpful, and I will talk to you soon. Peace.